Hi everybody, Dr. Kernel here. We are going to talk about using Jupyter Notebooks at the same time as we're working in Arc Pro. So we've been talking about some tools like kernel density that let us take point patterns and kind of aggregate them and look at them as a whole. What I wanted to do was show you how that can be accomplished kind of interactively within Arc Pro and Jupyter Notebooks. So we're going to use the Baltimore 911 data. This has been cleaned and projected. If you don't have this, you can certainly download that or use any other kind of point data. Should work fine for this lecture. So to start with, we're going to load a new project. So let's see here. I'm going to open this up with a new map. You can kind of set this to whatever you want. I'm going to leave it as the default for now. Which is generally not good form. You should be recording these in some location that's meaningful to you, not just buried in some folder. But that'll work fine for this lecture. Opens up obviously with a base map. We can drag and drop our data in, easy enough. And then this is the 911 data that we've been used to using. Now what I want to do is do the manipulations on this using Jupyter Notebooks. So it should be easy enough for you to go to run kernel density outside of using a Jupyter Notebook. But what if we want to use that? What we're going to need to do is create a new notebook. We're going to make it within our project. So this is project folder is my project 5. We're going to name it as before. They all have this .ipnynb. Probably it would stick this on the end of it if you don't put it on there, but always good to be ahead of the game if you can. This is going to be storing this within the geodatabase that comes with the project. So every time you start a new project in Arc Pro, it creates its own file geodatabase, and all of the data that you're working with is stored in there. Now, the Baltimore 911 data is not yet in there, so we'll actually do that next. But we've created our notebook. You'll notice that it doesn't appear on these tabs. I would think probably in a future version that would happen, but it doesn't happen now. And by the way, this new integration comes in Arc Pro 2.5, which as of this recording only came out, I think maybe about 2 months ago. So we're gonna open that up here. So we need to go to View. We're gonna open a catalog pane. We can see the databases that we've been working with, and within this project, we've got the IPython notebook. And let me actually just correct that. The IPython notebook is not dropped directly into the geodatabase. It's within the project folder. But once we have it here, we can open that notebook, and it's going to appear as a tab within our project. And there it is. So we can start scripting right in here. We can go back and forth to our map. One of the things that's kind of nice to do is if you float this up, you can, so it's just right clicking on it. If you move it down here, you can actually get these things kind of back to back. And I kind of like this view. This saves us some of the trouble of creating maps within our Jupyter Notebook. Again, here we're talking about using Jupyter Notebooks kind of interactively with our map panel and looking at the output. So slightly different take on kind of what we've been doing, which is more scripting A to B, follows the steps and makes an output. Here we're planning on running this stuff interactively. All right, so the first thing that I want to do is I actually want to get this data, which I just dropped into my, which I just dropped from my desktop in here, and I can work with this. That's totally fine. But what I want to do is actually put this into my geodatabase. So I'm going to export this quickly into my geodatabase, and you can see that it's bringing up this feature class to feature class tool. That's just kind of how Arc does things, kind of behind the scenes now. The default location here is my project 5, which is my project geodatabase, and I'm just going to change this to Baltimore _911. Hit run, And now all of this data is going to be in my geodatabase. So you can see that I've got two copies of it here, my original shapefile copy. This is my geodatabase copy, and I'm just going to remove that. I really only wanted to do that for convenience. You can skip this step for sure. It might be wise to skip this step if you want to not make multiple copies of your data. But here I'm just going to get rid of that. So I've got my Baltimore 911 data here. I've got the same problem as I had when we looked at this in the notebook. These dots are kind of piled one on top of another, and it's difficult to get a sense of the overall pattern. So what I want to do is write some Python that's going to help me with this here. How do I do that? What I want to do in this lecture is not just sort of type stuff out, but I want to encourage you to sort of solve these problems in a way that you can kind of remember. With that, let's open up a browser. Okay, so we've got our browser. How do we get started with one of these things? Well, the easiest way by far to get started writing scripts and stuff, if you're not very used to it, is to find a script that you've worked with before and use that to bridge. Writing code from scratch can be difficult, and it's much easier to sort of adapt code as you go. And that's actually a really important skill in the programming process, just kind of learning to take code that exists and kind of make it do what you want to do. So the last notebook that we did that's related to this was published in our Analysis in GIS folder. And we did this example of a Roanoke stormwater example. So we're going to start with this and make adaptations as we go. All right, so the first thing that we did when we were working with this data, this is the GeoPandas solution. What we want to do is the ArcGIS solution. The first thing that we want to do is we're going to move this data, or we're going to move this information over here. All right, so we're just going to load the stuff in wholesale. Do we need all this stuff? Probably not. We really probably aren't going to need these things, but loading a couple of pieces that you don't need is not the worst thing in the world. So we are importing the tools that we're going to need, ArcPy, the ArcGIS API for Python, which is brought in this ArcGIS.gis import GIS, which is a little arcane, but works just fine. All right, so we've imported our stuff. We can't do anything with it yet. So if we go back into our browser, what's the first thing that we need to do? We need to load this object for mapping. Now, we aren't actually going to need to do any mapping in here, but we can. And so we can run this bit and instantiate this GIS object, and that's what we would use for mapping. It's also what we're going to need to use in the next step. But I want to make one little adaptation here. One of the things that we didn't talk about is what this thing does and how it works. This bit up here at the top is essentially opening up creating an object that's going to let us interact with the ArcGIS API for Python, which is different than ArcPy. ArcPy is sort of just a Python replicate of all of the tools you've been working with your entire GIS career. This one is different. This one lets you interact with a lot of cloud objects. We are going to talk about that a little bit more. But one of the things we've really glossed over is authentication. So let's take a quick look at authentication and how it works for this. If we go back to our web browser here and we just do a quick search, and if we're looking for ArcGIS Pro Python Authentication, you're going to get, you'll find this page at the top here that says working with different authentication schemes. This is a bit here that is not really well ironed out. There are lots of ways to authenticate. The way that most people with an enterprise sort of think of that as sort of business level GIS stuff. They're going to authenticate in some of these ways down here. What we did in the past was this one. So we authenticated as an anonymous user, which is enough to get started. What we're going to do today is actually this one. Oh, let's just look for it at the top here. That'll save us some time. What we want to do is do connecting through ArcGIS Pro. And so we're going to do GIS equals GIS Pro. That makes these things a little less standalone, but in this case where we're working interactively between the notebook window and the data window, this will be just fine. So we're going to rerun this again, and now we've authenticated through Pro. Okay, going back to what we had before, we then defined our working directory. This is an important step anytime you're working with data. In this case, we're loading our project geodatabase. So what's our project geodatabase? If we go back again to, we're actually going to save our work here. If we go back to our catalog pane, this is our project geodatabase, myproject5.gdb. So because we're in here, we don't need a path. myproject5.gdb. All right, so that's our, we've defined our working directory. Now it's going to look in here automatically for our stuff, and any outputs that it creates are similarly going to get dropped into this geodatabase. All right, what else did we do last time? Well, we did this thing where we listed the layers in our working directory. Do we need to do that? Not necessarily, but it is a nice thing to do to make sure that we've defined this stuff correctly and we've loaded our stuff correctly. It's a quick check to make sure that everything is working right so far. And sure enough, we're talking to this list feature classes function. We're putting that into a variable called fclist, feature class list, and then we're asking Python to print that out. And so it comes back and it says the only feature class you've got here is Baltimore 911, which is correct. We've got that here. So far we know that everything is working great. What else did we do? Well, one thing that we did was we created a data frame so that we can interact with this stuff with pandas. We actually did this twice because we were working with not only point data but also watershed data. So we only need one of these. So we're going to bring in the SDF, we're going to bring in this line here where we're creating a spatial data frame out of a feature class, but we're not going to use storm points to do it. We're going to now use Baltimore 911. And if we go back, the next thing that we did was we looked for the first few rows of that. So we're just going to go ahead and do that in exactly the same line. Again, what is this doing? This is saying, let's just peek at the first 3 rows of our data set and make sure that we've done everything we want to do correctly. So we run this, and sure enough, here is our Baltimore 911 data. A couple of rows so you can just start to get the hang of what the data looks like. Okay. Where do we want to go from here? Well, what did we do last time? We visualized that, we created a map, and we plotted it. So let's just finish that. So we're going to copy this whole code block of visualizing data, and we're going to put it here. Except we're not working in Roanoke, Virginia anymore. We're working in Baltimore, Maryland. We're not using this watersheds thing anymore, so we can get rid of that line. And then all we want to do is we want to take our spatial data frame that we made up here. We want to make a map out of it. In that case, we had rendered these things as unique values using a column in our data. We don't want unique values generated for this one. That's going to be really overwhelming. And so we are going to just nix this whole section, which cleans up the code and makes it a little bit more readable. We're taking our spatial data frame, we're accessing a spatial functionality, which happens when it's integrated with ArcGIS Pro. We're using a plot method. I want to plot it as a map, and I'm going to use the map widget M, and then draw M. So if we do this, we're going to get a nice little map in our window, basically what you see over here. So this will take just a second to run. And there's our data. So we've sort of replicated a little bit of what we're doing on the left map panel right here. We're not really going to use this. We're gonna move on and use this kernel density tool, and I'm going to have it draw directly over on our big map here. And so if we want, we could just get rid of this. This is just sort of to see what we could do. So if this confuses you, feel free to delete this block. If you escape, you can see that it turns blue. You can actually come up under here and delete, where we go. You can delete the cells right here, and that goes away. Okay, so let's run some tools. All right. Okay, so again, the best way to get started with this stuff, anytime you want to run a tool in ArcGIS Pro, and this is probably true whether you're trying to use Python or not, is to look at the documentation. So what we want to use is kernel density for ArcGIS Pro. And if we jump to the first thing that we find here, this is exactly what we want to do, right? So if we scroll down, we can see sort of how the tool works. But at the very bottom of every tool in ArcGIS, there's a code sample now. And so that code sample is really helpful for showing you how to develop these things on your own. There are two code examples here. I'll zoom in a little bit so this is clear. There are two examples of this here. We've got a really nice condensed example. They're loading ArcPy, they're loading this, they're loading one of the spatial analysis tools, and then they're running kernel density on it. And we get a result that looks like this. These are the parameters for the output, and then we're saving that file to a location on the C drive. This example is a little bit more complete. It does exactly what this one does, but it separates things out. And in a way, I like the idea that we're setting these local variables. So I'm gonna copy this technique. We're gonna copy this data, and we're gonna put it in our project. So that's gonna look like this. Instead of, what do we need to edit? Instead of these as our in features, we need to set this to our Baltimore 911 data. You may remember some settings that work down here. Let's leave these alone for now. And then let's go back to our example. And here we need to execute the kernel density, so we're going to copy that over, and we paste it in like so. This should be enough to get us to run. So we hit Control Enter and we run this, but we get an error, and it says kernel density is not defined. There's actually a little bit here that we forgot to do, and we need to do it, otherwise this isn't going to work, and that's here. So where it says from arcpy.sa, so that's spatial analysis, import everything, which is fine. What that does, the kernel density tool, again you'll see this up at the top, is inside the spatial analyst toolbox, or license, if you want to put it that way. And so unless we import that particular tool, we can't use it. There is another way to phrase this, though, and so you can either copy this code. In fact, that's probably the easiest thing, so maybe we'll just do it that way. We're going to copy that code, and we're going to put it up here where it belongs. All right, we execute this code block. It's one of the nice things about Jupyter Notebooks is we can jump around. So we are loading that toolkit in there, and now if we go to run this, it will work, right? So when we did that import statement, it has given us access to this kernel density. This is our output. it looks okay. We can kind of turn this off a little bit, or maybe set the transparency down so that we can kind of see through it a little bit. That's kind of not so bad. Or we could do it the other way and put this on the bottom and put the transparency up on the top, whatever works for you. But you can kind of interactively see, well, how good of a job does this do capturing this? It does okay. We could probably improve that. And this is where the Python techniques really make things better. So what we need to do is set the search radius down. It's too big. It's kind of blobbing up. I want to make this smaller. So I'm going to cut that in half. And I can just hit Control Enter. And it's going to generate a new one right over top of the old one. Now, as you keep doing this, these things are going to keep showing up over here. So if you get confused, you can just sort of let one of these things go. This is starting to look a lot better, right? This is more like it's sort of capturing this, what looks like a corridor in here. We've got sort of a hotspot over here. We've got a bit of a hotspot over there. And I think this captures it fairly well. If you wanted to make more changes, you could set the cell size to a nice round number, which I think is always more pleasant. If you wanted to coarsen this up a bit, you could do that as well. And you can start to see how easy it is to sort of change the parameters and play with these things. So as you're working with this class for the rest of the term, and you're asked to sort of play around with these tools, this is a nice way of sort of playing around with those tools, just getting a sense of what these parameters do. It's a lot easier than bringing up the tool again and filling in all the values again and then hitting OK again. It just sharpens the revision process by a pretty good margin. So where did this data go? It's over here. We can do all the same tools with that. If we get one we like, we could do data, we could export the raster. That would certainly be one way of doing it. In the code base here, we have one little line here at the end that says save the output. This is kind of a nice thing to do if you're working within a project file and you want to consider that kind of throwaway data. When you get to a part that you like, you can save this stuff out. And so maybe I want to save this stuff out as temp final kernel density .tiff. So we can save that output, and then when we go to look for that in our temp folder, it will be right there. One last thing is, at this point, we looked at the layers in our directory. If we run this code block again, you'll see that the only thing that it finds in there is Baltimore 911. But if you go look in your catalog pane, you can see that all of the kernel densities actually got written into your project folder. So don't, especially if you're working with big data, you'll at some point want to clean these things out. It's a bit of a misnomer when it says you have to save them. That's only sort of true. You can see that once you delete them over here, then it deletes them over there. But what if you want to? Let's run this one more time. Okay, we got a new one. We'll look at our catalog pane. What if you wanted to see what was in here? Even though I can see that kernel density output, when I run this, I don't see it. And the reason for that is your raster is not a feature layer. So we want to add that in here. And the way that you do that is like this. We're going to ask to list the data sets that are in your current working directory. So we run this code block, and sure enough, there's our kernel density thing. So the split between raster and vector, again, kind of crops up again here. This is the request to list the vector files. If you had specified a working directory as a directory, not a geodatabase, it would list all the feature classes in there. But if you want to list out the rasters, that's a separate request, which again is a little bit awkward, but easy enough to see how that works. So with that, we'll wrap this up. We'll have an additional lecture on a similar topic here, but that should get you started. I would encourage you to try to use some of the other tools that we've been talking about in the spatial interpolation section, the temperature data, and try to work through doing some of this stuff with code as part of the notebooks that you're working on. It would be a good way to kind of sharpen up your the Python that we've learned in conjunction with doing some of the spatial analysis. So we'll wrap things up there. Thanks for listening, and we will catch you next time.